Hello, I welcome you all. The problem reads, determine the time needed for the load at B to attain a speed of 10 meters per second starting from rest if the cable is drawn into the motor with an acceleration of 3 meters per second squared. The second problem reads, the cable at A is being drawn towards the motor at velocity at speed equal to VA equal to 8 meters per second. Determine the velocity of the block. Alright, both these problems are coming from the Engineering Mechanics Dynamics 14th edition by RC Hibbeler. So let's start with case 1. There we go, case 1. What do we have as a 12-203? Right, that is case 1. There we go. So what do we have here? So let's draw our datum. So my datum, I have how many cables? 2 here, okay, and one is facing the other side. So I'll draw one datum like so, and then the other one like so. Okay, right, something like so. This one now, reference positive will be going in this direction like so. Okay, and then here we're going to have this like this. Okay, we'll have this, and we'll also have this, right? Okay, there we go. So we'll have this here, we'll have that there like so. Okay, there we go, there we go, right. And there we go, our reference here is going down, is our positive. Okay, right, so this is positive going down, and this is positive going this direction. Okay, like so. So let's call this one as SB, we call this one as SC, and then we call this one as SA. Okay, and then we do have these parts here, these constants. Okay, this one there, and also this one there, right? And also this one here. All right, so let's call this as C1, we call this as C2, and then we call this as C3. So let's write down the equations. We write down the equations. What do we have? We have SA plus SC plus C1, okay, equal to L1. Okay, if we are to find the first derivative of these positions, then we have VA plus BC is equal to 0. So let's go to the second one. What do we have? And we also have this constant here. This one we're going to call it C4. Alright, so the other one is SB, okay, plus 2 plus SB minus SC, okay, right? Then plus these constants, which are C, C2, C3, and C4 equal to L2. Okay, I copy this, maybe I bring it here like so that I make use of this space here. So if we were to work out the first derivative here, this just becomes a 3VB, okay, minus 2VC, okay, then the rest are all zeros because they are constants. 2VC then equal to 0. Alright, in this equation we can write this equation so that it gives us VC is equal to minus A, okay, minus VA, right? Mind you, we want to find the time needed for the loaded B to attain a speed of 10 meters per second. So we are concentrating on relating A and B because we've been given what have we been given? We've been given the acceleration. If the cable is drawn into the motor with the acceleration of 3 meters per second, so AV is already given to us. Okay, all right, so let's write down the accelerations here. So here this becomes AA plus AA plus, do we even need this? Okay, this we can come and write later on, come and formulate this later on. So VC is equal to minus VA. Let's plug this in, we get this one, okay, come and plug it there. When we do so, then we are going to have 3 VB minus 2 minus VA equal to 0. Okay, is that so? This one is 3 VB, okay, and therefore our VA, okay, is just going to be equal to 3 over 2 minus 3 over 2 VB, okay, and then this writing is in terms of acceleration, or we leave it the way it is. We know that our acceleration at A there, we've been told, is AA is equal to, and it's in the positive direction, 3 meters per second squared, and we know that AA itself is just equal to dVA dt, okay, and AA dt is just equal to dV, okay, right? So integrate both sides like so. So let's replace the value. So we have a 3 there, dt, integrating from 0 to t, all right, because they are telling us to say if this is starting from rest, okay, and then we have there our dv, this is from 0 to v, okay, and therefore our va, this particular case, just becomes equal to 3t, okay, so this is 3t. So what we'll do now is plug in this 3t here in this equation. We'll get this one, and then plug it in here. Okay, and once we do so, then we'll have 3t is equal to minus 3 over 2 VB, where VB, we've been told VB, we've been given VB already, which is 10, because the idea is to allow the load to attain this particular speed, and it is going up. Okay, it's going to be going up like this. Okay, it's going up. So if it's going up, our VB in this particular case becomes negative, right? So this is just going to be equal to minus 10 meters per second. So we replace this here, we replace this here, and once we do so, let me just create a boundary there quickly. Let me create a boundary there. Once we do so, then we are going to have 3t is equal to minus 3 over 2 times minus 10. Okay, all right, then 3 and 3 there cancels, minus and minus cancels, and therefore our t is just going to be equal to 5 seconds. Right, so we found the time needed for the load at B to attain the speed of 10 meters per second. So we are done with the first case. Let's go to case number 2. I think we can solve all of them, which is a 12-204. All right. So what are they asking us here to find? Here they're asking us, we have been told that the cable at A is drawn towards the motor at VA equal to 8 meters per second. Determine the velocity of the block. So in this particular case, we've been told that VA itself is equal to 8 meters per second. Okay, so it's going in this direction like this. Therefore it is positive, right? Considering our convention. So if this is the case, we already have the equation. This is the equation that we're using. We already found the equation. Okay, so our VA, we say this is equal to minus 3 over 2 VB, right? So we want to find the velocity for the block, which is VB. So writing this, our VB is just going to be equal to minus 2 VA divided by 3. Okay, so we can plug in this value there, can plug in this value here, right? Once we do so, then we'll have VB is just equal to minus 2 over 3 times 8. Okay, therefore our VB is just going to be equal to minus 2/3 of 8 2 over 3 times 8. This just becomes 5.33 meters per second, or VB is equal to 5.33. I remove that minus. This just simply means the block is going up. Okay, which is going to be negative because we assumed going down as positive. All right, I guess we are done. Let's outline the solutions. So we have t there, okay, equal to 5 seconds, and then we have velocity for the block B at B equal to 5.33 meters per second. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.